Hello out there. Today I'm going to be talking about the Pickering steam governor or general flow governor. Just to start with the basics, a governor determines how much of a fluid flows into an engine. So initially these were used for steam, later on they were used for gas mixtures. But the basic idea is that if you have rotary motion, and you're running a machine, you want it to be consistent. If you're running a lathe, you don't want the lathe to slow down when you dig a bit, make a deeper chip or something like that. So the steam governor was an extremely important invention, especially in the early Industrial Revolution era. The first steam engines were linear pumping engines, the Newcomen, the first generally accepted steam engine. It didn't necessarily need a governor because it was just going up and down pumping water. James Watt came along with the rotary engine and had a governor of his own design, a gravity governor. So there were big balls that would spin like this, and as it was increased, the balls would go up like this. And they ended up figuring out, okay, that's good, that's a great start, but it's going to be more consistent and more effective to use springs. They're always the same. You can put them in different orientations. So in 1862, Pickering patented this style of governor. 3 fly balls connected by multiple pieces of spring steel, thin spring steel. And as the speed of the governor increases, the speed of the engine, these balls pull out on these springs and the top goes down, if you can see that, and that pushes on a rod which pushes a valve inside this chamber downwards and shuts it off. So the faster the engine's going, the less steam flow is going in, up until a certain point when it's completely closed or just a little gap, and then the engine is running at its RPM that it'll be consistently running at. So the crank on the engine, the crankshaft would have a pulley, and that would be belted to this pulley, which would drive like so the governor. There's just a couple bevel gears here, and there's 2 rods basically, one rod on the top and then one rod on the bottom that are, there's a bit of a disconnect for safety purposes. That's part of what this mechanism on the side here is. If the belt running from the crank of the engine to the governor was ever to break, the governor in its mind would be thinking, engine is not running because it's not spinning, give it full steam. This not spinning, full steam, valve fully open, the engine would run so fast. Normally what would happen at first is that the flywheel would explode. Just big piece of cast iron going too fast, it would shatter. And in industrial engines, the size of those flywheels, they'd demolish buildings. They'd completely destroy the factory from a flywheel explosion. So they ended up coming up with little devices that would idle on the belt. And should the belt ever break, the idler would fall, and that would pop this spring ratchet, and this arm would shut the valve right off as a safety feature. So they came up with little modifications like this through the existence of these governors. But Pickering's model really held consistent from the 1860s all the way to the 1920s because it was such a good design. There were a few upgrades that I'll talk about, but the same configuration was consistent. This specific governor is a 2-inch pipe input made by the Waterous Company in Brantford, Ontario, Canada. It's the same as a Pickering model, but this is the complete one. I have another one, a 1.5 inch, that I'm going to disassemble here for you, reassemble in a bit, and I'll show you how it goes together. One of the other important things when it comes to governors is the way the valve works. It's a balanced valve. The balanced valve has 2 pieces that are both exposed at the same time to steam, and that's so that a single piece valve, it would be biased. If you have pressure on a standard globe valve, for example, something like this, a globe valve, as you open it, you're basically raising a limiter, a barrier, and then closing it again. If you have a lot of pressure on one side and you're trying to raise it, the pressure is working against you trying to raise it. The pressure is causing a bias. When it comes to governors, you want them to work as precisely and without interruption as they can. So the inside the valve here, there are two sections, and the steam is pushing on this part as well as this part at the same time, and it's inverse forces, so they cancel each other out effectively, and the governor can move this valve without much bias from the pressure difference. So that's makes quite a complex casting for this valve. This is the same valve, just disassembled. You have one layer here and one layer here. The input comes here, and when the valve opens, some steam goes right down through the bottom and some steam comes around and then to the bottom. So that's the way the balanced valve operates. This one's been a bit modified with some braze probably as a limiter, but I'll show you this being reassembled in a bit. I wanted to give a close-up of the inside of the balanced valve. So here you can see the top hole, and down in there you can see the second seat. And on the back you can see this void here is where the steam comes around the top and then goes down into the bottom. This is the internal part of the valve, and you can see its funky shape. It has these tapers here in alternate directions which allow it to open slowly. Some steam will start to sneak in the thinner part, so it's not all of a sudden boom, full steam if this was flat. Another interesting thing, a significant development for Pickering was what they called the ball ranger. The reason was, if you wanted to adjust the speed of your governor and the speed of your engine, there were only a few ways you could do it in the early days, and most of them were quite cumbersome. This spring system and ratchet was one way they said you could adjust it. You increase the spring tension, which increases the resistance against these balls, so technically you could change the speed a little bit. Many people didn't think they were very effective, so they needed something better. The other thing you could do was take out the main rod that this thing affects and shorten it or make it longer, but that was tedious and you had to completely shut down the engine. In 1907, Pickering patented this little device, relatively simple, called the ball ranger. What it did, it sat in here. You have a thread, and this little thing's a jam nut, a threaded rod and a little dial, and you have multiple ball bearings inside here. And what it did was, say it's all the way out, you have your bearings in here and your top rod is sitting here. As you tighten it, the ball bearings come out and bend around and push up. So they basically act as if you're lengthening the upper rod, which would be just the same as closing the valve. So if you were to tighten this and close the valve, your engine would need less steam. You'd slow down the engine. So this was an extremely easy way. You could do it while the engine was running. You could tweak it to whatever you wanted, and then you could set this jam nut and your engine would stay running at that rate. Here's a close-up of the ball ranger. I don't know if you can see on there, it says patented May 21st of 07. Just like that. Very simple to operate. Twist it. Your jam nut moves. Inside here you probably can't see, but this is where the balls go up and down, and there's a little pin so that the balls don't fall out. But that's the ball ranger. So that's 1907. They came out with a couple other modifications in 1907 to simplify the production and the working of the governor. This one here that I'm going to assemble for you is a 1907 patent. This one is a much earlier model. So without further ado, let's get on to building this 1.5-inch Pickering governor. So first things first, put the spindle back together. Has the 3 fly balls, and these are 2-piece balls, and they're in matching sets, so you can take them apart as long as you don't put that part on this part, the top on bottoms, you know, mix them up. Also, they have different offsets if you look here. I can tell also what's been rubbing, so there's a little bit of flat, not much. This one has a lot of flat, so I can tell it was against the washer, and this one has a fair bit of flats too. So I can tell it was against the washer, and there's this big kind of funky flying saucer shaped washer that goes in the middle of 2 of them right here. So I can tell this one's the middle. Whoops, this one is the bottom. No, this one's the bottom and this one's the top. So I'll put the top on first. Sometimes you have to, I let everything pretty well on this soak in oil at first. And sometimes you have to use the pipe wrench to get these off. So as long as I have it set up so that this part is above the center, if I'm using it as the top. So there we go. There's all the three aligned. I put them out of order. This one originally would have gone down here and these two the other way around, but that's all right. This doesn't matter that much. In this case, it doesn't influence it. This just acts as a limiter, so this thing determines how far these can go in, and it keeps these parts spaced here a little bit. So that's good. I'm just going to hand tighten these pretty well as much as I can. In the case of my governor, the leaf springs, or these springs, there's 3 per pack, and they were in really good shape. They're not all rusted and out of whack, so I didn't have to replace them. Just took the balls. So there's the complete spindle. It's quite nice. It's marked right here, made by Pickering Governor Co., Portland, Connecticut, USA. On the top it says made in USA, and here it says shaft revolutions 380. You'll see those change. A lot of the smaller ones are up closer to 500 RPM, and then there's a big serial number right here. And we have a patent date, May 21st, 07, and October 15th, 07. So this is the later of the Pickering style, as I was explaining before. So I can put this aside and move on to this, the upper part of the main housing. This is where the bottom rod goes. It's kind of nice. Everything comes apart easily because these things were in line after the steam oiler, so there's still this thick old tallow-filled steam oil on many of these parts. Next, I'll add the shaft where the driving bevel gear goes. The really nice thing with these governors is they're all put together with tapered pins. So it's like they're designed to be rebuilt, and everything is really forgiving. So, a little bit of oil out. Whoop. Got a bit excited. Make make a mess. Okay, bit of oil on there. As long as the taper for the gear, the large part is lined up for both. And as the end play would increase with wear in these gears, all you do is put a shim washer in between. But this specific governor has barely any wear on it, so. Don't really want oil on that. Might decide to fly out. This is a little quick shutdown lever. It acts to, if you hit it, it will release the ratchet tension, which is holding the valve up. And as soon as it does that, the valve will drop and it will shut down. It's like another type of safety automatic stop type device. This part here is the Sawyer's lever. So the next part would be installing this valve. It would come up from the bottom and it indexes with the ball ranger. So I lay that down. A little bit of oil on there. Ball ranger sits with the wide side up and the bottom goes into this part. This is the fixed part to the ball ranger. The balls don't go this way, they go into the upper rod. Now to align the top and bottom, there are dots that were put in from the factory. They should be able to go any orientation, but I want to keep this one the same. There's the dot right here and right here. There we go. So I'll finish the assembly now by putting on the spindle onto the rest of it. So I put a light coat of oil inside. There are washers, shim washers, that go on the bottom here, in between here and the base where it rests, to control the play this way. And then there's this retainer. It's just like a bushing with a set screw, and it also acts as an oil cup. You put oil into here and it'll trickle down and lubricate the lower bearing. So when I put the spindle on, I need to line this up at the same time and line up the set screw with its hole there. So I'll just put some more oil. Before I get too far, put this on. Make sure it lines up with the washer in the middle here, and then it goes on to the top bearing. Just drops in place. This, need to put the set screw on and that cup there. End play is slight. Now I put in the upper rod. This is the rod that the downward action applies force to, which then travels down and messes with the valve, and it's interrupted by this mechanism here that can shut it down quickly, or you can use the ball ranger basically to raise or lower this rod. And there's a little keyway you can see here on the bottom that indexes with the top part of the ball ranger so that this doesn't spin inside the housing. So again, I'll put a bit of oil on here. Slide that down through the center. spin it a little bit until there goes the keyway just fell in. And there's shim washers up here as well, so that this surface here, the nut on the top of the spindle, is pressing on the top of that rod. And there's also a hole in the top of this nut, which allows you to tighten the, to oil the top bushing. There, so that's that. And there's a complete Pickering governor. Working as it should. So now I'll put in these reducers, pipe bushings in the bottom, and go put it on my steam engine. Just need to tighten these last bolts in place. You can see how this works. You use this ratchet to tighten right there. And now this is holding the ball ranger mechanism up, which means fully open valve. As the RPM of this increases, this whole system pushes downwards. And if there's ever something goes south, you can trip this and all the resistance force holding it up is gone and the valve falls like so. So I might need to set this to one notch further. Oof, that's hard. Gee. There we go. And now maybe it'll, yeah, there we go. So there's the complete Pickering governor. I do still need a pulley, the driven pulley that goes above, lined up with the one on the engine. But for now, this is going to go on about an 8-horse Kenwood vertical engine. Kenwood was a brand sold by Sears. I'm not 100% on that because there's no markings on this engine. But yeah, hope you enjoyed this video. I'll give you a close-up here to see the beauty of the embossing on the valve chamber, if you will. There we go. Tune in next time for a comparison between the Pickering, the Gardner, there's a whole bunch of other types of governor that I'll try to go into. I'll get examples and compare them side by side. Have a good one.